hospitals. Deep in the tropical agricultural belt, millions of acres of cassava plants reach maturity. To meet industrial demand, specialized harvesters uproot the tubers. Speed is critical as cassava begins
boundaries. A continuous convoy of trucks transports 50 million tubers to the processing plant every single day. The logistics must be...
Upon arrival, every load is weighed and logged. This facility processes thousands of tons of raw root daily.
Hydraulic lifts dump the raw tubers into the intake hopper. This is the start of a highly automated journey from dirt-covered root to fine white flour.
This buffer stock ensures the processing line never runs empty. The factory consumes this mountain of starch every few hours. Large paddle washers tumble the roots in water. Friction between the tubers helps scrub away the heavy clay soil gathered from the fields. High-pressure jets provide a final rinse. The roots must be free of grit before entering the delicate peeling stage.
A density separator removes any remaining stones. Since cassava is lighter than rock, it floats over the trap while stones sink. Inside abrasive drum peelers, the roots rub against rough surfaces. The thick, toxic brown skin is stripped away, revealing the pure, white, starchy flesh.
The peeled roots emerge gleaming white. Continuous water spray prevents oxidation, which would turn the white flesh blue or brown. To facilitate grinding, heavy-duty choppers slice the tubers into uniform chips. This prepares the material for the rasping machine. The rasper is the heart of the extraction process. High-speed blades pulverize the chips, rupturing the cell walls to release the starch granules.
Rotating at 2,000 revolutions per minute, the rasper turns solid roots into a smooth, wet mash in a fraction of a second.
The resulting slurry is a mixture of fiber, water, and starch. Powerful pumps transport this heavy mash to the dewatering stage.
To ensure the flour is grit-free, the mash passes through hydrocyclones. Centrifugal force separates any remaining microscopic sand.
The slurry enters massive belt presses. High-tension rollers squeeze the mixture, forcing out the cyanide-laden water and reducing moisture content.
Removing water mechanically is far more energy efficient than using heat. The press reduces the moisture content by half in seconds. The output is a dense, damp cake. While significantly drier, it still contains too much moisture to be shelf-stable. For drying, the cake must be pulverized. Spiked rollers break the slabs into fine granules, maximizing surface area for the hot air to act upon.
The granules are fed into the flash dryer intake. Here, they meet a stream of hot air moving at over 100 kilometers per hour.
Inside this 30-meter tower, drying happens in just 2 seconds. The flash drying technique preserves the quality and color of the flour. Suspended in the hot airstream, moisture evaporates instantly. The rapid heat transfer dries the flour without cooking the starch. Cyclones separate the dry flour from the moist air. Centrifugal force pushes the heavy flour to the walls, where it falls into the collection hopper. The flour is now dry but hot. A cooling system brings it down to room temperature to prevent condensation inside the packaging. For premium baking flour, the dried granules are milled one last time. High-speed impact mills reduce the particle size to a fine, silky powder. Large oscillating sifters classify the flour. Only particles fine enough to pass through a specific mesh screen make the final cut. Coarse fibers are separated and collected. Nothing goes to waste. This fiber-rich byproduct is sold as high-quality animal feed. Before storage, the flour passes through high-strength magnets. This ensures no metallic contaminants from the machinery enter the food supply.
The finished flour is stored in massive climate-controlled silos. This buffer allows packaging to continue even if the processing line stops.
The finished flour is stored in massive climate-controlled silos. This buffer allows packaging to continue even if the processing line stops. In the packaging hall, robotic arms handle the heavy lifting. They place empty bags onto the filling nozzles with perfect timing. High-speed augers fill 50-kilogram bags in seconds. Electronic weighers ensure every bag meets the exact trade weight.
Automatic sewing machines seal the bags. A final metal detector scans the sealed bags. This is the last line of defense to guarantee food safety.
Batch codes and expiry dates are printed on every sack. This allows the flour to be traced back to the specific day and time of production. Rollers flatten the bags to distribute the flour evenly.
Uniform bags create stable, safe pallets for stacking.
A robotic palletizer does the heavy work. It stacks the 50-kilogram bags in an interlocking pattern for maximum stability.
Stretch wrapping secures the load. It protects the flour from moisture and dust while keeping the stack stable during transit. Forklifts move the finished pallets to the storage warehouse. This facility can hold weeks' worth of production, ready for export.
In the lab, samples are tested for purity, viscosity, and pH. The flour must meet strict international standards for baking quality.
Microscopic analysis confirms the starch granule integrity. High-quality milling ensures the flour has the right texture for cakes and breads.
Omerts. For supermarket shelves, a secondary line packages the flour into 1-kilogram retail bags.
These retail packs are boxed for distribution to grocery stores. Cassava flour is becoming a popular gluten-free alternative worldwide.
Sustainability is key. Wastewater is treated in anaerobic digesters, producing biogas that helps power the factory's dryers.
The captured biogas and dried peelings fuel the boilers. This closed-loop system reduces the facility's carbon footprint.
To prevent downtime, a dedicated maintenance team works around the clock. Sharpening the rasper blades is a daily necessity.
Advanced dust collection systems keep the air clean. This protects workers' health and prevents the risk of dust explosions.
The entire process is monitored from a central control room. Automated systems adjust flow rates and temperatures to maximize efficiency.
At the loading dock, finished flour is loaded into shipping containers. This product will be exported to bakeries and food manufacturers globally.
Cassava flour is prized for its baking properties. It mimics wheat flour, making it a perfect gluten-free substitute.
In the oven, the flour transforms into golden, crusty bread. It offers the same texture as wheat, but is entirely grain-free.
The result is a soft, airy loaf. It's hard to believe this started as a muddy root in a field just days ago. Beyond baking, the flour is used to make noodles, thickeners, and snacks. Its versatility drives the global demand.
It is also the base for crispy snacks and crackers. The starch expands when fried, creating a light, crunchy texture.
Regular sanitation is strictly enforced. Machines are washed down to prevent bacterial growth and ensure product purity. Filter cloths are changed regularly to maintain dewatering efficiency. A clogged belt would slow down the entire production line.
Viscosity tests measure the thickening power of the flour. This is a critical specification for industrial food customers.
The factory operates around the clock. During peak harvest season, the line runs 24 hours a day to process the crop.
This industry supports thousands of local farmers. A guaranteed market for their crop provides economic stability for the entire region.
While similar, cassava flour includes the fiber, whereas starch extracts it. This facility can adjust its process to produce either product. Maintenance at height is required for the tall drying towers. Inspecting the cyclones ensures optimal airflow and drying efficiency.
Recycled water is used for the initial root washing. This significantly reduces the factory's fresh water consumption.
Tons of peels are generated daily. They are diverted to compost facilities or used as biomass fuel, closing the loop.
Stack stability is tested to ensure safety. The flattened bags interlock, preventing the pallet from collapsing during shipping.
High-security seals protect the cargo. The container will not be opened again until it reaches its destination, potentially thousands of miles away.
From the air, the scale of the operation is clear. It is a finely tuned machine designed to convert nature's bounty into a global commodity. The factory employs hundreds of skilled workers. Providing a safe, comfortable working environment is essential for productivity.
A massive inventory of spare parts is kept on site. If a motor fails, it can be replaced in minutes to keep the line moving.
Safety briefings start every shift. In a factory filled with heavy machinery and high-pressure steam, vigilance is mandatory.
Exporting food requires rigorous documentation. Certificates of analysis and origin accompany every shipment.
Throughout the day, the silos fill steadily. By sunset, hundreds of tons of finished flour have been produced.
As production winds down for cleaning, the intake pit is washed. It must be spotless before the next harvest arrives at dawn.
This humble route travels far. From this factory, cassava flour reaches kitchens and factories on every continent.
Finally, the product reaches the consumer. A high-quality, gluten-free flour ready for home baking. From 50 million tubers to a delicious meal, this is the incredible journey of cassava flour.